April 13th, 2029. That is the exact date permanently circled on the calendars of planetary defense networks across the globe. It is not a vague forecast, nor a worst-case scenario pulled from a distant science fiction novel. It is a fixed point in time when a massive cosmic threat will cross the thin line separating deep space from our atmosphere. By the time this date arrives, humanity will witness something never recorded in modern history. By the end of this video, you are going to understand exactly what this close approach actually means, not as an abstract headline to scroll past, but as a physical reality with a precise timeline and heavy orbital consequences. You will understand why this specific asteroid, named Apophis, is categorically different from the space rocks that zoom past Earth every few months, why its sheer size changes every calculation for planetary defense teams monitoring our night skies. And you're going to realize something that almost no mainstream media coverage has truly touched upon: the fact that the gravity of our own planet will fundamentally alter the future path of this giant rock as it screams past us. We will get to that exact mechanical shift very soon, so stay with this. Start with the raw cosmic physics. Asteroid 99,942 Apophis is not a harmless stray pebble floating silently in the dark. It is a monstrous mountain of rock measuring roughly 1,100 feet wide. To visualize that scale correctly, picture a skyscraper standing over 340 meters tall, hurtling through the vacuum of space at immense speeds. The average asteroid passing Earth stays millions of miles away, completely invisible to the human eye. At those deep space distances, planetary defense teams simply observe them through powerful telescopes, calculating trajectories with broad margins of error. But Apophis is not staying far away, not even close. On that specific Friday in April, it will plunge down to a distance of approximately 32,000 kilometers from the surface of our home planet. That is roughly 19,900 miles. That distance is not just close in cosmic terms. It is a structural invasion of our immediate orbital space, bringing the rock closer than our own weather satellites. Think about that reality for a moment. This giant celestial body will pass beneath the very orbit where our highest geosynchronous satellites operate daily. It is coming inside our zone of artificial space infrastructure with no physical barrier. When an object of that massive scale enters a zone normally reserved for communication hardware, the environment changes completely. Scientists who have spent decades tracking near-Earth objects are preparing for a historical event unlike any other. There is something critical happening at that distance that most casual space enthusiasts completely miss. Stay with me past the 4-minute mark, because what comes next explains why researchers are genuinely fascinated by this unique cosmic flyby. The distance between Earth and Apophis during this close approach will be a mere 1/10 of the distance to the Moon. This represents one of the closest approaches of a large asteroid in recorded human history. Current trajectory calculations confirmed by global space agencies show zero risk of impact for the year 2029. In fact, advanced orbital modeling guarantees safety from this specific rock for the next 100 years. So, we are completely safe from a direct collision during our lifetimes. But the absolute proximity of the event creates a completely different kind of phenomenon that planetary defense experts must analyze with extreme precision. Because the asteroid will skim so close to us, it will actually become visible to the naked eye. People across parts of Europe, Africa, and Asia will watch a bright point of light moving across the night sky. It will look like a fast-moving star, visible without a telescope or binoculars. Imagine looking up and seeing a city-destroying threat sailing cleanly through the sky, close enough to see with your own eyes. If an object of this magnitude were to ever impact Earth, the destruction would be absolute. We are talking about city-destroying energy capable of wiping out entire metropolitan areas and causing widespread environmental devastation. That immense destructive potential is exactly why NASA and other global agencies keep an intensive, round-the-clock watch on its path. Small shifts in orbital calculations matter immensely when stretched over decades of space travel. Here is the core variable that scientists are watching closely as the 2029 date approaches. When Apophis passes through Earth's powerful gravitational field, it will experience an intense physical tug-of-war. Our planet's gravity will not pull the asteroid into an impact path for that day, but it will exert immense tidal forces on the rock. These forces are strong enough to subtly alter its future orbit forever. As the asteroid skims past, Earth's gravity will twist and bend its trajectory, launching it into a brand new orbital path around the Sun. This means all previous long-term calculations will need to be entirely rewritten. Here is the moment you stayed for, the part that reframes the entire planetary defense conversation. Apophis is the ultimate poster child for why tracking cosmic threats matters so much for the future of our civilization. It represents a real, observable space threat arriving in just a few short years. While the immediate danger is zero, the lessons we learn from this close encounter will define how we protect Earth moving forward. Let us examine the history of this cosmic giant to understand why it caused so much panic initially. Discovered in the year 2004, Apophis immediately sent shockwaves through the astronomical community worldwide. Early tracking data suggested a terrifying possibility. Initial calculations indicated a high probability of impact for the year 2029, causing experts to rank it higher on the hazard scale than any prior object. For a brief period, the world faced the real prospect of a catastrophic collision. Scientists scrambled to gather more radar data, refining the orbital pathway to see if humanity was truly facing an existential crisis. Subsequent observations thankfully ruled out the nightmare scenario for 2029. Yet, the initial scare completely changed the way global governments viewed the necessity of permanent space tracking systems and planetary defense protocols. Now, as the approach year draws closer, space agencies are preparing dedicated missions to meet the asteroid during its flyby. NASA is redirecting an advanced spacecraft to study the rock up close as it passes us. The spacecraft, originally sent to collect samples from another asteroid, will arrive at Apophis just days after its closest approach. It will orbit the giant rock, observing how Earth's gravity affects its surface structure. Scientists expect to see dramatic changes on the asteroid itself. The powerful gravitational pull of our planet could trigger surface landslides, shifting the loose rocks and dust covering the exterior of the massive object. It might even cause internal tremors, shaking the core of the asteroid as it endures the tidal forces of our planet. This rare event provides a natural laboratory for scientists to study asteroid physics in real time. Understanding the internal structure of these objects is vital for future planetary defense. If we ever need to deflect a dangerous asteroid, we must know whether it is a solid rock or a loose rubble pile. A solid rock reacts differently to deflection methods compared to a collection of loosely bound boulders. Apophis will give us the exact data required to design effective deflection systems for any future emergencies. Consider what this means for our technological readiness. We are getting a free front row seat to observe a potentially hazardous object passing closer than our own operational hardware, without any actual risk of impact. It is an unprecedented opportunity that allows us to test our observation networks, coordinate international space agencies, and verify our tracking models under the exact conditions of a real cosmic emergency scenario. The international community is taking this event incredibly seriously. Telescopes across every continent will lock onto the bright streak of light, gathering continuous data as the mountain of rock glides swiftly across the sky. Amateur astronomers will also play a massive role, documenting the event from their own backyards. It will be a unifying moment for humanity, watching a reminder of cosmic vulnerability pass harmlessly overhead. Yet, we cannot let the safety of this specific pass make us complacent about the broader universe. The solar system is filled with millions of near-Earth objects that have not yet been fully cataloged. While we know where the large ones are, thousands of smaller city-destroying rocks remain hidden in the glare of the sun. A surprise discovery could leave us with very little time to prepare a response. That is why projects like the Near-Earth Object Surveyor Space Telescope are so critical. These advanced systems are designed to spot dark, hidden asteroids years before they ever get close to our orbital path. Apophis serves as the ultimate wake-up call, proving that massive space rocks do indeed come incredibly close to our home. It transitions the concept of planetary defense from theoretical math into an active discipline. When you look up at the sky on that fateful Friday night, you will see a vivid demonstration of orbital mechanics in action, a stark reminder that our planet exists in a dynamic cosmic neighborhood. The precise geometry of the flyby is truly astonishing. Traveling at tens of thousands of kilometers per hour, the asteroid will cross our orbital plane, briefly becoming a temporary neighbor to our highest satellites. Engineers managing our communication networks must monitor the flyby to ensure no unexpected electrostatic interactions occur. While a physical collision with a satellite is statistically unlikely, the extreme proximity demands absolute caution. Every major space tracking center will be operating at maximum capacity during those critical hours. Data streams will flow constantly between international teams, validating orbital paths and measuring the precise distortion caused by Earth. This distortion is the key to understanding the next 100 years of the asteroid's journey. By measuring how much its path bends, scientists can project its future position with absolute certainty. Without this precise measurement, the subtle gravitational nudge from Earth could introduce tiny variations that compound over decades. Over long periods, even a fraction of a degree shift can change everything completely. That is why the 2029 encounter is not the end of the story. It is merely the beginning of a brand new chapter in tracking this specific, potentially hazardous object across the solar system. We must remember that space defense is a multi-generational responsibility. The systems we build today, inspired by objects like Apophis, will protect our descendants from catastrophic events centuries down the line. The technology required to alter an asteroid's path has already been successfully tested in recent years. We proved that we can change the trajectory of a distant space rock by crashing a spacecraft directly into it. That historic test demonstrated that humanity is no longer helpless against cosmic threats. Unlike the dinosaurs, we have the intelligence, the technology, and the capability to rewrite our own celestial destiny. But execution requires early warning, and early warning requires continuous tracking of objects like Apophis. If we lack the data, even the most advanced deflection technology becomes completely useless in a real crisis. As the final minutes of the 2029 flyby conclude, the asteroid will hurtle back out into the deep void, leaving behind a wealth of scientific data that will occupy researchers for decades. The insights gained will refine our understanding of how the solar system formed and evolved. These ancient rocks are pristine time capsules, holding secrets from the birth of our planetary neighborhood billions of years ago. By studying its composition up close, we learn what materials were present when Earth was forming. This connects the discipline of planetary defense directly with the profound questions of our own ancient origins. So when the headlines begin to buzz in the spring of 2029, you will know the real story behind the sensational text. You will understand the physics, the mechanics, and the strategic importance. It is not an apocalypse story, but a triumph of science and preparation, a vivid display of cosmic clockwork passing harmlessly by, teaching us exactly how to safeguard our future among the stars. The countdown is ticking forward every single day, bringing this historic event closer to reality. Every second brings the mountain of rock closer to its date with Earth's gravity, and we are completely ready. Share this insights with others who want to look past the media hype and understand the actual science. The universe is full of wonders, and this close call is one we will never forget. Make sure to stay informed as new tracking updates roll out from global space agencies over the coming months. The journey of Apophis is a testament to human curiosity and our shared cosmic journey. Let us dive deeper into the precise regional visibility expected during that historic evening. The global tracking networks have mapped the exact path of visibility, showing that billions of people will have an opportunity to watch. As the sun sets across the eastern hemisphere, the bright point of light will emerge, cutting a silent path across the constellations. It will travel faster than typical satellites, creating a spectacular view for observers. Educational institutions worldwide are already planning major viewing events to engage students in science. This single cosmic event will inspire a new generation of astronomers, engineers, and planetary defenders to look toward the heavens. The psychological impact of seeing a massive space rock with the naked eye cannot be overstated. It transforms abstract cosmic dangers into a tangible reality that anyone can witness simply by looking up at night. This shared human experience will reinforce the necessity of international cooperation in space exploration. Protecting our planet is not the job of a single nation, but a unified responsibility for all of humanity together. The data gathered by international tracking stations will be uploaded to shared global databases immediately. This ensures that researchers from every country can analyze the structural changes and orbital shifts in real time. Advanced radar facilities will bounce signals off the asteroid's surface, creating highly detailed three-dimensional maps. These images will reveal the exact shape, craters, and boulder distributions across the entire object. We will see the precise details of its topography, helping us understand how impacts over millions of years have shaped its form. Every crater tells a story of its long journey through the void. The countdown to April 2029 is a reminder that we live in an active universe. It challenges us to advance our technology, refine our observations, and remain ever vigilant against the dark. Humanity has reached a point where we no longer have to fear the sky. Through science and determination, we have turned a potential cosmic catastrophe into the greatest educational opportunity of our century. As the giant rock fades back into the darkness of deep space, our planet will continue its orbit safer and more knowledgeable than ever before. The story of Apophis is our success story. Keep your eyes on the stars and stay curious about the mechanics of our universe. The future of planetary defense is unfolding right now, and you are a part of this incredible era.